Hi kids. All right, you guys should have done page 10 in your packet. That should have introduced you a little bit to lightning. You guys also should have read about that guy that got struck by lightning. So I want to actually kind of go through some of the basics with lightning as far as, how a lightning strike occurs, what a lightning rod does, and then why you're safe inside your car. So we're going to talk about those basic things with you today, seeing as I'm not there today. So here we go. First, lightning. If you have, typically for during a thunderstorm, you get big, tall, anvil-shaped clouds. So these are my clouds, and when I say big, tall, I mean from the bottom of the cloud to the top of the cloud, you're talking probably maybe 5 miles, something like that. So big. Because the top of the clouds typically are up above like maybe 33,000 feet, and they're so high that the top of the clouds are, the temperature is well below freezing, which is why even in the middle of the summer, it can be really warm outside. You can still get hail, which is essentially just ice, because the top of the clouds are so high up that it freezes. But what happens, and let me draw the ground. So the ground is down here someplace. And maybe this is, miles of air separating them there. But what happens in a thundercloud, or a thunderstorm, is that the bottom of the cloud typically develops a negative charge, top of the cloud typically develops a positive charge. So negative charge, positive charge. As far as why the charge develops like that, this is one of the things that scientists are not 100% sure on, and to be quite honest, I think that's kind of cool that scientists don't know everything. They still have things to figure out. But one of the theories they think is that maybe the ice, as it floats to the top of the cloud, because ice is less dense than water, tends to rub past the water as they're going one way or the other. And as they rub past, they cause charging by friction, and the ice tends to give up the electrons, so the water at the bottom of the cloud tends to have a negative charge. At the top, it tends to have a positive charge. That's one theory. Is that true? Who knows? But the key is this actually develops first. So the charge in the cloud develops first, and this process continues. You get more negative, more positive, more negative, more positive. Well, if I have tons of negative charge being built up in the clouds, then what's going to happen in the ground down here, by induction, positive charge is going to get drawn up to the top. So positive charge gets drawn up to the top. And let's say maybe that there's a tree here. Here's my tree. Okay. Well, this tree is also going to get covered in positive charge. So this tree is going to get covered in positive charge, and the negative charge is going to get pushed down to the bottom. So the negative charge is going to be down here below where you can actually see, but there is negative charge down there. Actually, let me just draw it here so you can actually see it. But I have actually induced a charge in the ground. So first, build up a charge in the cloud. Second, you're going to induce a charge in the ground where you get this positive charge. Now, eventually, this process keeps going. So you get more negatives, more positives, until eventually the air can't hold the charge back. And when the air can't hold the charge back, that's when the charge jumps. Boom, that's your lightning bolt. Okay? Or, boom, that's your lightning bolt. Because sometimes you get cloud-to-cloud lightning. Sometimes you get cloud-to-ground lightning. Can they predict the lightning? Absolutely not. It could strike the tree twice in a row. It could never strike the tree. If you're standing over here, okay, this person over here is going to get covered in positive charge. Well, if they get covered in positive charge, their hair might stand up. This was from that lightning video you watched. If your hair ever does stand up outside, don't take pictures like those people. But if maybe this person is going to have a lightning strike hit them. Okay? Typically, not always, but typically lightning will strike the tallest object. So the reason it's a bad idea to go and stand underneath the tree is that if that tree is the tallest object, the lightning is going to strike the tree. And a lot of times, as the lightning works its way down to the ground, the lightning may actually jump from the tree to the person to the ground, or the lightning might actually come up from the ground and get the person there. Also in that video, the Tom Skilling video that you watched, there is, if there's a bunch of cows huddled around that tree, all those cows could get struck by lightning, and sometimes they do when they all turn, they all die. So again, lightning, build up a charge here, induce a charge down there, the charge builds up, charge builds up, charge builds up until the air can't hold it back, and then the charge jumps. That would be an example of charging by friction. If you've ever, and everybody has, but you go and you touch a doorknob and you go, bzz, you get zapped. Well, that's exactly the same thing as a lightning bolt. It's just a lightning bolt is many, 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 many times greater than that. So, but that is exactly how it occurs. So, we okay with how a lightning strike occurs, I hope. Next, let me pause it.